So starting with our new unit is on transformations, and we're going to be covering translations for today. Now the concept or idea of a transformation means that you're taking a shape and you're making some kind of change to the original image, whether you are changing the orientation. Orientation means like direction that it's facing, or you might be changing the size, and we'll be talking about that one. They didn't mention the transformation that changes size, but we will be getting into that. It's a fourth transformation. We'll get into that next week. But what we're going to be talking about is a translation for today. So a translation is the idea of just sliding a shape without changing anything about it. So if I were to take this diamond and I can move it to the right, that is a translation. If I move it up, that's a translation. If I move it diagonally, that is a translation. It's just the sliding of the figure. The figure does not rotate or turn. It does not flip or anything of that sort. It stays in its exact same orientation and just moves across a plane. Okay? So we're just sliding from one position to another. Now, what's really important to make sure you understand is that the original image is still going to be congruent to your translated image. And again, congruent means it's going to be equal. So that's very, very important to understand. And another thing that's really important to understand is that this is the only transformation that maintains both size and orientation. It is the only transformation that maintains both size and orientation. So size, you guys know what size means, but again, orientation basically means that it is the same direction. Orientation means same direction. Okay, it does not change the direction that it's facing, meaning when you've got points that are labeled, so if you've got a shape, the shape is typically labeled by its vertices. So in this process here, we've got triangle A, B, C. When we translate it, the positioning of A, B, and C still remains the same. Now, if you notice, I've done what's called two translations or two transformations. And after each of my transformations, I have a little marking behind it. What this marking represents, this means A prime and B prime and C prime. Okay? So when you have transformed a shape, whether it's a translation, a reflection, a rotation, or a dilation, the new transformed figure is called a prime figure. Now, if you happen to transform it more than one time, then that's when you start getting into what's called double prime or triple prime. So the amount of transformations that you perform will indicate the number of prime that it is. So here, because I translated it twice, this would be called a double prime, and B double prime, and C double prime. So it just continues to go on. If I translate it a third time, I would call it A triple prime, B triple prime, C triple prime. Okay, so prime is indicating that there was a transformation that occurred. If you don't see the phrasing prime or that little marking, the apostrophe behind it, or the doubles, okay, like the quotation marks as some people would call it, then that means it was not a transformation that occurred. It's an original image. Okay? All right, let's look down here. When we are translating, what's important to know is that you typically move in specific directions. If you happen to be moving left or right, then that's going to have a change to your x-coordinate. If you're moving left or right, it's going to have an effect on the x-coordinate. Now, if we move to the left, when we move to the left, that means that we are going to subtract from our x value. And when we move to the right, we add to the x value. So if I say, hey, I'm starting at point 39 and I'm going to move to the right 7 spots, then I'm going to take my point 39. 3 would be my x value, and I would add 7 to it because I'm moving to the right. If I said I'm moving to the left, I would subtract 7 away from the 3. Okay, and then the same thing for when we're moving up and down. If we're moving down or up, that has a change or effect to just your y coordinate. When we're moving down or moving up, it affects the y coordinate only. Okay, so if we move down, you would subtract from the y. And if we move up, we're going to add to the y. And again, when I'm talking about a coordinate plane or a coordinate point, remember coordinates are written as x comma y. Coordinates are always written as x, y. Your x value is always your first, your y value is always your second. And when you're plotting a point, you always start at the origin, or that 0, 0 point, and the x tells you how far left or right to go, and the y tells you how far up to go, up or down to go. Okay, and then from that point, that's when we would start following our translations. Go ahead and flip it on over to the back. It's a very quick mini lesson for today. So for here, I want to translate the following 3 points by moving 2 units to the right and then 5 units down. So 2 units to the right means that I'm going to take my x value and I'm going to add 2. I'm going to take whatever my x value is and I'm going to add 2. And then 5 units down is an effect on the y. So that means I'm going to take my y value and I'm going to subtract 5. So looking at each one of these points, each one of my x's happens to be the first value here. So I'm just going to put a plus 2 underneath each of them. And then where my y value happens to be, which is that 4, the positive 3, and that positive 1, I'm going to go ahead and write that I'm subtracting 5 away from those values. Okay, and once it's been translated, I then have my new points. I have my A prime, B prime, and C prime. Okay, let's start with A prime. We're going to do negative 3 plus 2. When we take negative 3 and add 2, we're just going to get negative 1. Then for the y value, we're going to do 4 minus the 5. That will also give us a negative 1. Okay, so we're at negative 1 for A prime. For B prime, we do 1 plus 2, which is a positive 3. And we do 3 minus the 5. That comes out to a negative 2. So B prime is located at the point 3, negative 2. And then C prime, we're going to take negative 4 and add 2. That gives us negative 2. And we're going to take 1 and subtract 5. That gives us negative 4. So there's where C prime is located, at negative 2, negative 4. Okay, I want you guys to try problem 2 on your own. All right, let's go ahead and go over this. So for the x, who can tell me what is the x prime coordinates going to be? Bridget? Very good. Negative 2 and a negative 1. We were moving 1 unit to the left, so it doesn't always have to be written in the order of, left, right, and then up and down. It sometimes might be, hey, here's the up and down coordinate or the left and right coordinate second. So we're moving left 1 unit, which means that we're going to take our x value and subtract a 1 away from it. So I'm subtracting 1 away from negative 1. That gives me negative 2. And then I'm moving 3 units down, which means I'm going to take my y value and subtract 3. So I'm taking 2 and subtracting 3, I get a negative 1. Who can tell me what the y prime coordinate is going to be? Trang? 5 and a negative 6. Good. So again, we're going to subtract 1 away from 6. That gives us a positive 5. And then we're going to subtract 3 away from negative 3. That gives us negative 6. And then finishing it off, what is our z prime coordinate going to be? Himna? 1 and negative 8. Very good. So we're going to subtract 1 away from the 2. That gives us a positive 1. Then we're going to take negative 5 and subtract 3. That's going to give us negative 8. So there's our new coordinates. Now for problem number 3, it says translate the following point 6 units up and 3 units to the right. But the point is not a specific number. The point is an expression. But it's the same exact process. If we're moving 6 units up, 6 units up is going to have an effect on which coordinate? The y. Up and down is your y, right? Think of it kind of like, how many legs does a y have? 1. So all it can do is jump up and down, right? X has 2 legs, so it can run. It can run back and forth, left and right. Okay, so the y only has 1 leg. All it can do is jump up and down. Okay, so the up movement is our effect on the y. We're going to be taking our y value and adding 6 to it. And then for the units going to the right, 3 units to the right, that's going to affect the x. So we would take our x value and add 3 to it. So in this case, I'm going to be adding 6 to this y expression, and I'm going to be adding 3 to this x expression. So really, you're just rewriting these expressions. You're focusing on what x minus 7 plus 3 would be. So you're only focusing on the numbers. So what's negative 7 plus 3? Negative 4. So then our f prime, the x coordinate, now becomes x minus 4. Okay, and then for here, again, we're focusing on the y coordinate, or those y numbers. So we're taking a positive 5 and adding 6 to it. What's positive 5 plus 6? 11, a positive 11. So this would become y plus 11. So it's very much the same process, except you're just simplifying the expression first instead of focusing on a number. All right, sometimes you're given the point and then given the prime value. You're already given the translated point, and you have to figure out what the rule was. What's the translated rule? So in order to do that, you're going to start at A and figure out how you processed it and moved to A prime. So it's just a matter of setting up an equation. Okay, let's write that down. That we're going to start at A, and then we're going to end at A prime. So when we're talking about our x, coordinate, that means we're starting at negative 6. We did some form of a transformation, so we always just put plus, because we don't know whether it's a positive or negative yet. So we just put plus. And then we did some form of transformation to the x that had us ending up at A prime, which was 12. So we've just created an equation here. How do I solve this equation? If I've got negative 6 plus x is equal to 12, Ray, what would I do? Good. We're going to get rid of this constant by adding the opposite, right? The inverse. We're going to add 6 to both sides here. That gives us x by itself. X happens to be a positive 18. Since it's positive, that means that we moved to the right. So I'm going to write that down. That is moved to the right because it was positive. We move to the right because it's positive. Okay, then we're going to do the exact same thing for the y. For our y, we started at 2, did some kind of transformation, and we ended up at -4. We start at 2, did some form of a transformation, and we ended at -4. So the same process. To solve it, we would subtract 2 from both sides. And that puts us at y equaling -6. So since the y's change was -6, that means that we moved down. We moved down because it was negative. We moved downward because it was negative. So our final answer is the rule, which is 18 to the right and 6 down. There's our rule. We moved 18 to the right and we moved 6 down. Okay, I want you guys to try problem 5 on your own. You're starting with point A, and you're going to translate it 2 units up, then 4 units to the left. Then you're going to perform another translation of 1 unit to the right and 9 units up. We want the final coordinate. Since we're doing 2 transformations, what is our final coordinates labeling going to be? Double prime. Because we did 2, we are going to have a double prime set up. All right, let's go ahead and go over this last one. So we're translating it 2 different times. Who can tell me what is the value for a double prime going to be? Kenneth, why don't you tell me what you got for a double prime?
Positive 1, x, and positive 10.
So close. It wouldn't be positive 1. It's actually going to be a negative 1. So it's -1 and then the positive 10. So let's take a look at that one. So we started at point 2 and -1. And then we're going to go 2 units up. Remember, up is going to affect your y. And then 4 units to the left. So that's going to affect the x. Then we're going to do this transformation again, which is 1 unit to the right, which affects the x. And 9 units up, which is going to affect the y. Okay, so for here, if I'm starting at the point, and I'll go ahead and write my point in black real quick. If I'm starting at the point 2 and -1, my first transformation with going 2 units up means I'm going to add 2 to the y. I'm going to take this y value and add 2 to it. And then I'm going to take this x value and go to the left, which means I'm going to subtract. So I'm going to subtract 4 away from my x unit. Okay, that's going to take me down to a prime. So 2 minus the 4 is going to come out to a -2. And then -1 plus 2 is going to come down to a +1. So that's where a prime is located. But I don't want a prime, I want a double prime. So now we're going to take that a prime of -2 and +1, and we're going to do the second transformation. So for the second transformation, we're going to move 1 unit to the right, which means we're going to take our x value and add a 1. Then we're going to use 9 units to the left, so we're going to take that y unit and add 9. Okay, so we're going to do -2 plus 1, and we're going to do +1 plus 9. And that'll take us to a double prime, which is at a -1, because -2 plus 1 gives us -1, and then a +10, because 1 plus 9 is 10. Yes? Not yet. Okay, any questions about translations? Okay, so what you're going to be doing today, and I'm going to go print this out real quickly. I changed my mind. I was going to have you on the computers, but I think I would like you not on computers today at all. And instead, we're going to do some workbook pages. So I'm going to go make some copies of these. This will also be printed and located on Google Classroom in case you've misplaced yours. That means it is due when? Tomorrow. When tomorrow? Is it at the end of class? Very beginning of class, because we're going to check it together. Okay, so you need to make sure that you get this whole thing done. I've taken some stuff out. So if you see me having some squiggly stuff through it, it means you don't have to do that problem. So like problem number 8, you do not have to do. And then of course problem number 12 is already done for you. They usually do that. I cross off 13, 14, and 15 because we've already done a bunch like that. Number 16, I wrote a little footnote next to it, that there are 2 questions that number 16 is asking. So that means how many answers should you have? 2 answers. Okay, it's asking you, what exhibit is Julio located at? And then it's asking you, if the felines exhibit is located at 3-1, what are the coordinates of Julio's new location going to be? So you're going to put what his current location would be and where his new location is going to be after you've done the translation. Okay, and then of course we have a whole bunch of stuff on the back. Now, just because I wrote some of these coordinate things down doesn't mean that you don't have to write them down for other problems. So I got lazy, I didn't write them for here. You should be writing down the prime units here. Okay, make sure you understand the difference between prime and double prime. Okay, stop.